Hello there, and welcome to LUMI verse NL. Maybe you've had a long day, or maybe you simply find peace beneath the rhythm of the stars. Tonight, you don't need to do anything. Just rest. Let your body grow still, your breathing slow, and your thoughts drift, because together, we're going to wander through the universe itself, not one planet or galaxy, but the vast unfolding of everything that has ever been. Imagine the universe as a great ocean of time and light. It expands quietly, carrying with it the story of creation and of you. Most scientists agree that this ocean began about 13.8 billion years ago, born in an instant of brightness and heat. That number comes from observing how the universe stretches, and from a faint glow that fills all of space, the cosmic microwave background, a whisper from the dawn of everything. But not all measures agree. Some ancient stars seem too old, their light older than the age we've assigned to the cosmos. Perhaps time itself flows differently than we think. Perhaps dark energy, the invisible breath pushing space apart, has changed with age. The universe keeps its secrets gently. We still call it 13.8 billion years, but in truth, no one knows how long it has been dreaming. When we look into the dark, we see not emptiness, but distance. The further we look, the further back in time we travel. Every glimmer in the night sky is a message, billions of years old, telling us that light is patient, that it remembers, and that somewhere beyond, creation continues. So tonight, as you close your eyes, think of that. You are surrounded by ancient light photons born near the beginning of time, still crossing the darkness to find you. You are not apart from the universe. You are its quiet witness, resting within its motion. The cosmos expands, and you breathe with it, gently, endlessly. If this calm journey brings you peace, let it linger. There are more stories waiting in the stars. In the quiet dark between stars, there are worlds with no suns to call home. Astronomers call them rogue planets, giant wanderers that drift freely through the galaxy, untethered, unseen. They do not orbit a star. They do not rise or set. They move alone, wrapped in cold and endless night. Some of these worlds began like ours, cradled by starlight, warmed by gravity, shaped by chance. But somewhere along the way, chaos intervened. A passing giant, a collision, or a violent shift in gravity cast them loose from their birthplaces. Now they float silently between the stars, invisible except when they pass in front of distant light. Others may have formed entirely alone, not as planets, but as failed stars, brown and dim, stillborn from the cosmic nursery. There may be billions of them in the Milky Way, perhaps more than the stars themselves, each one a frozen sphere wandering through the dark. Its surface locked in eternal twilight, its sky empty but for the faraway glow of the galaxy. Imagine standing there. No dawn, no dusk, only the faint curve of starlight brushing the horizon of black. A silence so deep that even thought feels like an echo. Yet even these lost worlds belong. Gravity still guides them, and the galaxy still holds them in its invisible web. They drift, but they are not forgotten. Their journeys trace unseen lines through the vast structure of space, proof that in the universe, nothing is ever truly still, and nothing ever truly lost. If our planet were flung adrift, Earth would glow faintly for a time, its oceans freezing, its air crystallizing. But beneath the ice, life might cling on near volcanic heat, in hidden seas. A whisper that even in endless night, warmth can survive. As you breathe tonight, think of those distant wanderers, planets without sunrise, without sound, moving through eternity with quiet grace. They remind us that motion itself is a kind of music, and that even in isolation, there is belonging. If this calm exploration helps you rest, let the feeling stay, because the next part drifts deeper into the universe's oldest rhythm: death, rebirth, and the cycles of infinity. In the stillness of deep time, even the universe may breathe. For all its vastness and silence, it might not be a single story that began once and stretches forever. Some physicists believe the cosmos could move through endless cycles, expansions, contractions, rebirths, like a heart beating slowly across eternity. In the standard model of cosmology, our universe began with the Big Bang, an instant of unimaginable density and heat, and has been expanding ever since. Galaxies drift apart, stars burn and fade, and over trillions of years, everything cools toward quiet darkness. That is the conventional end, the slow heat death of all things. But there are other ideas, whispered between equations. Perhaps expansion isn't forever. Perhaps, as space stretches, gravity will one day gather it back again. Some theories call this the Big Crunch, a reversal, where the universe collapses inward until it becomes dense and hot enough to ignite another beginning. From that singularity, a new universe might emerge, a big bounce. In this vision, there was never a true start, never an absolute end, only a rhythm of collapse and renewal. The universe, then, could be infinite in time, cycling through creation like a tide that rises and falls over unimaginable ages. Each cycle would erase the structures of the last, yet leave behind subtle traces, echoes of what once was. Some researchers have even looked for these echoes, faint circular imprints in the cosmic microwave background, like fingerprints of previous universes pressed into our own. Nothing certain has been found, but the idea lingers, serene and strange, that existence itself might be a repeating breath, not a single exhale. And if that's true, then every galaxy, every life, every moment is part of a repeating pattern, a single note played in an infinite song. Perhaps the Big Bang wasn't the beginning, but a continuation, a quiet moment in a rhythm too vast for human sense. Imagine it. Eons of expansion followed by slow return, the cosmos folding back into itself like a wave withdrawing from shore. Then, in perfect stillness, a new explosion of light. Matter reborn, stars rekindled, time beginning again. The old, giving birth to the new, in a silence deeper than memory. It's a thought that brings both humility and peace. If the universe truly cycles forever, then nothing is wasted. Every particle, every star, every breath you take could be part of a story that never truly ends. Even the light around you might have shone before in another age, another version of reality, now returned to wander through space once more. So, when you look up at the night sky, remember, the universe may not just be expanding, it may be remembering. Each flicker of starlight could be the echo of 1,000 earlier worlds, rising and falling in endless rhythm. And within that rhythm, you too are part of the pattern made of the same atoms that once belonged to suns, carried through cycles of time, finding peace in their own rebirth. The cosmos expands, collapses, and begins again, and through it all, something quiet endures, a balance between nothing and everything, a whisper across infinity that says, we have been here before. If this journey through timelessness calms your mind, let it settle like starlight. Next, we'll drift further back to the moment before transparency, when light itself was first set free, the beginning of all that could ever be seen. Long before stars or galaxies ever formed, the universe was a glowing fog, hot, dense, and filled with light that could not travel freely. Every particle of matter and energy was tangled in constant collision, scattering photons before they could move more than a whisper's distance. There were no stars to shine, no darkness to hold them, only brightness without direction, a universe that glowed but could not see itself. For nearly 400,000 years after the Big Bang, this fog endured. The cosmos was a vast, radiant ocean of plasma, a sea of charged particles, endlessly interacting, but as space expanded, it began to cool. Temperatures dropped just enough for protons and electrons to finally join together and form the first atoms. And when they did, the universe changed forever. Light, for the first time, was free. Photons that had been trapped for ages could finally move without constant interference. The fog thinned, and the cosmos became transparent. That moment, the release of the first light, still lingers today as the cosmic microwave background. It is the oldest signal we can detect, a soft echo of creation itself, stretched and cooled across the entire sky. Every direction you look, that ancient light surrounds you, faint, invisible to human eyes, but ever present. Those photons have been traveling for more than 13 billion years, carrying with them the record of the universe's youth. We can still hear their memory as a gentle hiss on old television screens, a quiet background to existence. When astronomers map that faint glow, they see tiny variations, ripples in brightness and temperature, differences no greater than 1 part in 100,000. Yet, those small imperfections are what allowed everything else to form. Where the light was slightly denser, gravity gathered matter. Where it was thinner, space opened wide. From those differences came galaxies, stars, planets, and eventually, us. It's humbling to realize that the structure of the cosmos, the beauty of every spiral and nebula, began as subtle vibrations in a fog of light. Tiny fluctuations, magnified by time and gravity, became the architecture of existence. Every mountain, every breath, every thought, all trace their lineage back to that luminous mist. And still, the background remains cool, constant, and everywhere. It's not the light of stars, but the light before stars, a reminder that illumination came before shape, that brightness existed before vision. If you were to stand in deep space, far from any galaxy, you would still be bathed in this ancient glow, a temperature of just 2.7 Kelvin, a whisper of the first dawn. It is the faint warmth of eternity, filling even the emptiest corners of the universe. In that glow, there is serenity, a calm older than time as we know it. When you close your eyes and drift towards sleep, imagine that light, a memory billions of years old, still traveling, still gentle. You are surrounded by it right now, whether you feel it or not. The universe, before it had stars or names, already shimmered with possibility. And that soft radiance, stretched thin by time, still holds the first breath of everything we will ever know. Next, we'll move forward to the first true beacons of the cosmos, the stars that burned 1,000,000 times brighter than our sun and gave birth to everything that followed. After the fog cleared and light was set free, the universe entered its next great transformation. Out of the cooling hydrogen and helium, gravity began to weave new patterns. Across the darkness, matter gathered into denser knots. And within those invisible seeds, something astonishing happened. The first stars were born. These were not stars like our Sunday. They were immense, wild, and short-lived population 3 stars, forged from the purest elements, untainted by heavier atoms. With no carbon, oxygen, or iron to cool them, they grew enormous, some hundreds of times the mass of the Sunday. They burned with unimaginable heat and brilliance, shining 1,000,000 times brighter than anything in our night sky. For a few million years, they ruled the universe, cosmic giants blazing in the silence. Their lives were brief, but their deaths reshaped everything. When they exploded, they scattered the first heavy elements, the iron in your blood, the carbon in your breath, the calcium in your bones across the cosmos. Those ancient supernovae seeded the next generation of stars, planets, and eventually life itself. We will never see these first suns directly. They lived too long ago, and none remain today. Yet their fingerprints persist in the chemistry of ancient gas clouds, in the makeup of every world that formed after them, in the atoms of our own bodies. Every star that twinkles now carries a trace of those early fires. Astronomers using the James Webb Space Telescope have begun to glimpse light from galaxies that existed when these first stars were still shining. That light has traveled for more than 13 billion years, stretched and softened by time. When we observe it, we're not just looking across space, we're looking across history itself, to an era when darkness gave way to fire. It's strange to think that even before Earth existed, before our sun began to burn, the universe had already known light and loss. The first stars lit up the cosmos, then perished, giving everything that would ever exist its raw material. Without their brief brilliance, there would be no us. Imagine that moment, the sky filled not with constellations, but with titanic blue suns, their light rippling through newborn galaxies, illuminating dust and gas like lanterns in fog. The universe itself was awakening, painting its first patterns in starlight, and then, almost as quickly, they vanished. Their fuel burned away, their cores collapsing, some into black holes, others scattering into nebulae that would one day form new stars. Creation and destruction, perfectly balanced, the first heartbeat of cosmic evolution. Every photon you see tonight carries a piece of that history. When starlight touches your eyes, you're feeling the echo of those ancient flames. The universe remembers every flash of brightness, every pulse of energy that shaped its story. So, as you drift deeper into calm, think of this. The light that once illuminated the first dawn is still here, softened, slowed, and spread across space. The same light that brushes your skin, that fills the air around you, that hums gently in every corner of existence. The stars you see are not only points of fire, they are time itself, shining. Their glow is proof that even from destruction comes beauty, that endings can become beginnings, and that the story of the universe is one of endless renewal. Next, we'll turn toward the rare and extraordinary planets made not of rock or gas, but of crystal. Worlds born from pressure so intense that even light would bend within them. Among the countless worlds that orbit distant stars, some are unlike anything we could have imagined. In the far reaches of the galaxy, astronomers have discovered planets so dense, so brilliant in structure, that they could be made almost entirely of diamond. These crystalline worlds form in solar systems very different from our systems, where carbon outweighs oxygen and pressure reigns supreme. In such environments, when planets form from the dust of ancient stars, carbon atoms may bind together under extreme heat and compression, creating a lattice of pure diamond deep beneath the surface. The result is a world both familiar and alien. A planet the size of Earth or larger, with a crust of graphite and a mantle of glimmering crystal. It would not sparkle like a gem, for its surface would be far too hot and dark, hidden beneath clouds of metallic vapor. But beneath those veils, immense structures of diamond could extend for thousands of kilometers, a world forged not in fire, but in pressure. One of the most famous candidates is a planet orbiting a pulsar, the remnant of a dead star that spins with mechanical precision, sending out rhythmic pulses of radio light. The planet itself is small, dense, and ancient, likely the carbon core of another star that once orbited too close, stripped away until only its crystallized heart remained. In essence, a diamond star, endlessly circling the corpse of its companion. Such worlds remind us how diverse the universe truly is. Not every planet glows blue with oceans or breathes with air. Some are made of gas and ice, some of iron and storms, and some impossibly of jewel and memory. They are monuments to cosmic variety, each shaped by the chemistry of its birth. If you could stand upon one of these worlds, the view would be surreal. The horizon would shimmer faintly beneath a dim Sunday. The sky, dark but reflective, might scatter faint glints from the crystalline ground. The sound beneath your feet, if sound could travel there, would be the low hum of gravity pressing against solid light. Though unreachable, these planets tell a quiet truth. Beauty in the universe is not rare. It only changes form. Sometimes it burns, sometimes it shines, and sometimes it hides beneath the surface, waiting to be discovered. And what makes them even more extraordinary is that the same process that creates these diamond worlds happens on a smaller scale within our own cosmos, inside dying stars. When massive stars exhaust their fuel, their cores collapse into dense remnants. Under incredible pressure, carbon within them can crystallize, forming structures billions of times larger than any diamond found on Earth. There are even white dwarfs, the final stage of smaller stars, that are slowly cooling into immense diamond spheres, solidifying over billions of years into galactic jewels. Our sun, one day, will become one of them. When it burns its last hydrogen and fades into a white dwarf, it too will cool and crystallize, turning into a vast diamond drifting silently through space. A final transformation from fire to light, from star to stone. In that thought lies something tender. Even the most powerful stars, those that once illuminated galaxies, will one day rest as silent crystals, shimmering faintly in the dark. They do not disappear, they change. The universe, it seems, has always been a craftsman of transformation. And in the endless workshop of time, it turns even death into beauty. Next, we'll travel beyond these hidden worlds to explore the shape of everything itself, the geometry of space, the curve of infinity, and why the universe may have no edge at all. It's natural to imagine the universe as something with a boundary, a great sphere surrounded by darkness, stretching outward until it ends. But the truth is far more mysterious. According to Einstein's theory of general relativity, the shape of the universe depends on the matter and energy it contains, and current evidence suggests that space itself may be curved, perhaps even infinite, without walls, without edges, without a true outside at all. To understand this, imagine standing on the surface of Earth. From where you are, it looks flat, You can walk in a straight line for thousands of kilometers, and the ground seems perfectly level. But if you keep going long enough, you'll eventually return to where you started, not because there's an edge, but because you've been traveling along a curve too vast to notice. Now replace the surface of Earth with space itself. It might work the same way, but in 3 dimensions. If you could travel in a perfectly straight line across the universe, you might, given enough time, return to your starting point, not by looping around a border, but by following the gentle curvature of space-time. In this sense, the universe could be finite but unbounded, endless in journey, though not infinite in size. The cosmic microwave background, that ancient glow left from the Big Bang, helps us test this idea. By measuring how light waves stretch and curve across the sky, scientists can estimate the geometry of the cosmos. So far, the data shows that space is remarkably flat, but flat on a cosmic scale may still mean very gently curved, bending over distances so large that no human or telescope could ever perceive it. If that's true, then every beam of light, every path of gravity, every galaxy's motion is subtly guided by the fabric of this cosmic curvature. Space doesn't just contain things, it shapes them. The geometry of the universe is the stage upon which all of existence unfolds, and yet this geometry is not static. As the universe expands, the curvature evolves. Dark energy, the invisible force driving cosmic acceleration, pushes galaxies apart faster and faster, flattening space like a balloon being inflated beyond measure. What began as a dense, tightly curved cosmos may now be stretching toward near-perfect smoothness. But what if the opposite were true? If the universe contained slightly more mass than it does, gravity would eventually overcome expansion. Space would curve inward, and everything would collapse into itself. A grand reversal, called the Big Crunch. Too little mass, and expansion continues forever, leading to cold, infinite isolation. Our reality seems balanced on the thin edge between these fates, a universe almost perfectly poised between curvature and flatness. It's humbling to think that we live inside something whose shape we can never truly step outside of. We can't look around the universe any more than a fish can look around the ocean. We are within the medium itself, suspended inside the very space that bends and stretches to carry our existence. If you could see the universe from beyond its dimensions, perhaps it would resemble something like a vast, glowing bubble of curved light, not a sphere floating in darkness, but a self-contained reality folding gently into itself. No edge, no border, only continuity. So when you gaze at the night sky and the stars seem to fade into forever, remember, you are not staring into emptiness. You are looking along a curve, one so immense, so subtle, that it feels infinite. And in that curve lies everything that ever was and ever will be: stars, galaxies, atoms, and the quiet observer that is you. The universe may have no wall to reach, no end, to find only a horizon that expands as we move toward it. It doesn't need an edge to be complete. It simply is, unfolding softly in every direction. Next, we'll drift inward past the grand shape of the cosmos and into the hidden structures within. The invisible halos, the unseen matter, and the mysterious substance that silently passes through you, even as you sleep. In the calm of every night, as you lie still and breathe, something extraordinary is happening. Through your body, through the walls around you, through every atom on Earth, dark matter is flowing, invisible, silent, and unstoppable. This mysterious substance makes up most of the universe's mass, yet we cannot see it, touch it, or trap it. It does not glow. It does not absorb light, and it does not collide with ordinary atoms the way normal matter does. But it reveals its presence in one powerful way through gravity. Galaxies spin faster than their visible matter allows. Stars at their outer edges move as if pulled by an unseen hand. Clusters of galaxies bend light more than their mass should permit. These cosmic motions make sense only if something invisible is there, forming vast halos around galaxies, structures that hold everything together. Without dark matter, stars and planets would drift apart. The Milky Way itself would unravel. We are immersed in this invisible sea. Our galaxy floats inside a colossal halo of dark matter that extends far beyond its visible edge. A sphere hundreds of thousands of light-years wide. As the Earth orbits the Sun and the Sun orbits the Milky Way, we drift through that halo like a small boat moving through a deep, silent ocean. Trillions of dark matter particles are thought to pass through every square centimeter of your body each second. They leave no mark, no sound, no sign that they were ever there. And yet, without them, the structure of the universe would collapse. They are the quiet architects of everything we see: galaxies, stars, even the space between. Scientists have built vast underground detectors in hopes of catching even a single interaction. Crystals buried beneath mountains, tanks of liquid xenon shielded from radiation, waiting for the faintest flicker of contact. But so far, dark matter remains perfectly elusive. Whatever it is, it does not behave like anything we know. Some theories suggest it could be made of weakly interacting particles, ghosts of matter that rarely collide. Others imagine entire shadow worlds, hidden realms of particles that form their own galaxies, invisible to ours but moving alongside them. We don't yet know which is true. We only know that something unseen gives the universe its shape. Even now, in this quiet moment, that unseen web surrounds you. Every movement of your body, every orbit of the planets, every beam of starlight bending through the cosmos is guided by its gravity. It is the silent frame beneath all creation, the invisible skeleton of the universe. And yet, despite its power, dark matter is calm. It does not burn, it does not collide, it does not shout. It simply is, like a cosmic memory present everywhere, influencing everything, but never revealing itself. It's poetic, in a way. The visible universe, all the stars, the planets, the glowing nebulae makes up less than 5% of everything that exists. Everything we see is just the light upon the surface of an ocean. The rest, dark matter and dark energy, is the deep water beneath, unseen but essential. So when you gaze at the night sky, remember that you are looking at only the faintest hint of reality. Most of the cosmos is hidden, flowing silently through you. Through the planet, through the endless web of galaxies that drift through space. And in that thought, there is comfort. Because if dark matter holds the universe together, then even in our own small lives, what is unseen may still be what binds us. Let yourself rest in that idea that invisible forces can carry strength, that silence can shape everything. For even as you sleep, the universe moves through you, gently and endlessly. If this quiet journey has helped you feel at peace, let the calm remain with you. In the next part, we'll follow the faintest trails of light to galaxies made of almost nothing, and to a strange, cold region of the cosmos that shouldn't exist at all. In the quiet reaches of the universe, there are galaxies that glow but hold almost no stars. They drift like ghosts, vast clouds of gas and dark matter, faintly shimmering against the background of eternity. When astronomers first discovered them, they were puzzled. How could something shine without the billions of suns that give galaxies their light? These spectral systems are called ultra-diffuse galaxies. Some are so transparent that if you stood inside one, you might not even notice. The stars would be few and far between, lonely embers scattered across unimaginable distances. A single star might lie thousands of light years from its nearest neighbor, its glow swallowed by the dark. Some of these galaxies may have been torn apart by gravitational encounters, pulled and stretched by larger companions until their stars were stripped away. Others may never have formed many stars at all. Their gas too thin or too cold to ignite new light. A few seem to exist entirely in the shadows, rich in dark matter but poor in visibility, reminders that the universe can be full of presence yet appear empty to our eyes. In a strange way, these dim galaxies mirror something universal. The idea that not all brightness comes from what we can see. Their quiet glow, spread thin across the cosmos, tells us that light can endure even when it has little to burn. But the mysteries of the night do not end there. Across the cosmic microwave background, the faint afterglow of the Big Bang, astronomers have found a region unlike any other, a cold spot, hundreds of millions of light years across, where the temperature is mysteriously lower than the rest of the sky. It's not just a small dip, it's vast, silent, and unexplainable. Some believe it could be the imprint of a massive cosmic void, a region of space where galaxies are scarce and gravity weaker. Others think it might be a statistical fluke, a ripple of randomness from the universe's early moments. But a few daring minds have proposed something even stranger, that it could be the scar of a collision between universes. According to certain cosmological models, our universe may not be alone. During its first fraction of a second, space may have expanded so quickly that multiple bubble universes formed, each with its own laws of physics. If two bubbles ever collided, the impact could leave an imprint, a bruise in the cosmic fabric. The cold spot might be that ancient scar, frozen into the background of space itself. No one knows for certain. The universe offers its clues softly, never all at once. What we do know is that the cold spot stands as one of cosmology's great enigmas. Not a violent anomaly, but a quiet contradiction. It reminds us that even after centuries of observation, there are still questions we cannot yet translate into answers. And yet, there's beauty in that uncertainty, because the unknown invites wonder, and wonder keeps us awake inside the infinite. The cold spot doesn't disturb the calm of the universe, it deepens it. It's a reminder that stillness, too, can hold secrets. Above all, these dim galaxies and this frozen patch of sky show us that the cosmos is not uniform. It is textured with differences, ripples, absences, and surprises. Even the darkness has character. So as you breathe, imagine floating beyond the Milky Way, drifting past clusters of light, into regions where galaxies fade like mist, and the temperature of space drops to nearly nothing. In that endless quiet, the only sound would be your own pulse, matching the slow rhythm of creation. Out there, between faint galaxies and forgotten voids, the universe whispers something profound, that emptiness is never truly empty, and that even silence, the deep cosmic silence, is full of meaning. Rest for a moment in that thought, because next, we'll turn closer to home, to our moon, its slow retreat, and the delicate gravitational dance that connects us to it across the ages. Every night, the moon rises over our world, steady, luminous, and patient. It feels eternal, like it has always been there, watching the oceans rise and fall, holding the rhythm of our tides. But the truth is that the moon is slowly leaving us. Each year, it drifts about 3.8 centimeters farther away from Earth, roughly the speed at which your fingernails grow. This quiet separation began billions of years ago, when the moon first formed. Back then, the Earth spun much faster, completing a day in just a few short hours. The moon orbited close enough to fill half the sky, its gravity tugging fiercely at our oceans. Those tides acted like invisible brakes, slowing Earth's spin while pushing the moon outward, a delicate exchange of energy that still continues to this day. The mechanism is simple, yet profound. As the moon's gravity pulls on the oceans, water bulges toward it, creating tides. But because Earth rotates faster than the moon orbits, the bulge lags slightly ahead. That offset pulls the moon forward in its orbit, giving it energy, which causes it to spiral outward. In return, Earth loses a tiny bit of its rotation speed. Days grow longer, imperceptibly, year after year. Over billions of years, this subtle dance has reshaped both worlds. When life first appeared in the oceans, days on Earth lasted only 6 hours. Now, they last 24. In another few billion years, that slow drift will continue until both Earth and Moon become tidally locked, each showing only one face to the other, turning together like a pair of partners frozen in an endless waltz. From the surface, that change is invisible. The moon still glows the same, still traces the same path across our skies. But if you could rewind time, you'd see its ancient presence, enormous, looming, and bright enough to paint the seas with silver daylight. The Earth would have been restless then, its tides rising like mountains, crashing across continents with a force we can barely imagine. It's humbling to realize that even something as familiar as the moon is not truly still. Its motion is constant. Its distance ever increasing. The night sky is a slow story, one of drifting companionship, written in millimeters and eons, and there's poetry in that distance. For as the moon slips away, the tides soften, the days lengthen, and the balance between motion and stillness evolves. What we lose in proximity, we gain in harmony, a quieter Earth, turning ever more slowly beneath a gentler sky. The same gravitational music plays throughout the cosmos. Stars in binary pairs orbit and exchange mass like dancers touching hands. Planets tug on their suns tug on each other, and every motion ripples through the fabric of space. Nothing moves alone. Every orbit, every rotation, every heartbeat of matter is connected to something else. So when you look up at the moon, you are not seeing separation, you are witnessing continuity. A graceful, unfolding relationship between worlds that has lasted longer than life itself. It is not a farewell. It is a long, slow wave of motion, one that reminds us that change can be gentle, and that distance, too, can be love. And somewhere, billions of years from now, when the moon has drifted far enough, Earth will rise in its sky like a small, pale memory. The two will face each other eternally, still connected, still circling, still sharing the same ancient gravity that once pulled the tides and now pulls the quiet of eternity. Every orbit, every turn, is a reminder. Nothing in the universe stands still, not even what seems eternal. Everything drifts, softly, toward balance. Now, let's turn from our familiar satellite to stranger pairings, stars so close they share their outer layers, their fates intertwined in spirals of light and gravity. In the vast theater of the stars, some of the most beautiful dances are also the strangest. Across the galaxy, pairs of suns orbit so closely that their outer layers begin to touch two blazing spheres of plasma locked in a delicate gravitational embrace. These are binary stars in contact, and they move with a rhythm both violent and graceful. From a distance, they look like a single shimmering point of light, but up close, each star feels the pull of the other. As one grows larger or older, its surface swells until gravity from its companion begins to draw its outer gases across the space between them. What follows is a silent exchange, rivers of starlight flowing from one sun to another. Sometimes the transfer is steady, a quiet balancing act. The larger star donates part of its mass to the smaller one, keeping both stable for millions of years. Other times, the process becomes chaotic. Matter spirals between them like glowing threads, the exchange accelerating until one star swallows the other completely. When this happens, their union can lead to transformation, a sudden surge in brightness, a nova, or even the birth of an entirely new kind of star. In rare cases, the collision ends in an explosion so powerful that it briefly outshines entire galaxies, leaving behind a neutron star or black hole. But more often, the result is simply a merging of lives, two stellar hearts, becoming one. These celestial partnerships tell us something profound about how nature works. Even among the most massive and luminous objects in existence, there is connection. No star is entirely alone. They orbit, they trade, they influence, and they evolve together, a quiet reminder that even in the cosmic scale, companionship is part of creation. Astronomers estimate that more than half the stars in our galaxy exist in pairs or systems of multiple stars. Some revolve far apart, never truly touching, while others move so close that they share a single envelope of gas. Their light flickers rhythmically, dimming and brightening as they eclipse one another, turning night itself into a heartbeat that can be measured across space. If you could stand on a world orbiting such a system, the sky would never know true darkness. Two suns might rise together, bathing the horizon in double light. Or one could sink below the edge of the world while the other still blazes, painting the landscape in shifting hues of gold and crimson. Shadows would bend and blur, stretching in multiple directions at once. To witness it would be mesmerizing, a world of perpetual dawn and twilight, where time itself seems to flow differently beneath twin fires. Yet within that beauty, there would also be fragility, for in such close proximity, balance is fleeting. One star's loss becomes the other's gain, and their fates remain entwined until one finally yields to gravity's quiet insistence. In a sense, binary stars mirror the relationships that fill the universe at every scale. Planets drawn to suns, galaxies pulled toward one another, atoms held together by invisible forces. All of existence is a conversation between attraction and release, between motion and stillness. The stars teach us that connection need not be peaceful to be beautiful. It can be turbulent, luminous, and ever-changing. The energy between them is what makes the cosmos shine. And perhaps, in a poetic way, that's what keeps the universe alive. The endless exchange between things that touch, drift apart, and reunite again. In their shared light, we see the story of creation itself. Two burning hearts moving together through the void, shaping one another simply by being near. For the cosmos is not a place of solitude. It is a web of relationships, of orbits and harmonies, of push and pull. Every collision, every exchange, every shared gravity is a verse in its song. And in that infinite choreography, Even destruction becomes art, and every touch leaves behind light. Next, we'll step beyond the blazing stars and into the deepest darkness of all, where even light bends, and where space itself hums with the quiet energy of the vacuum. When we imagine space, we often think of emptiness, a vast, silent nothing stretching between stars. But the truth is far stranger. Even in the most remote regions of the cosmos, space is never truly empty. According to quantum physics, the vacuum is alive, a restless ocean of invisible energy, constantly shifting beneath the surface of existence. This strange hum is called quantum fluctuation. In every cubic centimeter of space, particles and antiparticles appear and vanish endlessly. They come into being as pairs, one of matter, one of antimatter, borrowing energy from nothing, living for a fraction of a second, and then annihilating each other in silence. To our eyes, this sea of creation and disappearance is invisible. Yet, its effects ripple across the universe. It was these fluctuations, magnified during the earliest moments after the Big Bang, that seeded the galaxies. Tiny, random variations in the density of energy became the foundation for structure, the first hints of difference in an otherwise uniform cosmos. The galaxies, the stars, the planets, and even us all are descendants of that quantum restlessness. In a sense, every atom in your body began as a vibration in the vacuum. What we call nothing is actually the birthplace of everything. Physicists sometimes refer to this phenomenon as vacuum energy, and it may be connected to one of the greatest mysteries in modern science: dark energy, the force that's causing the expansion of the universe to accelerate. It seems that the vacuum itself has pressure, a kind of energy that does not fade as space grows. Instead, the more space there is, the more energy fills it. This quiet, persistent force pushes galaxies apart faster and faster, stretching the very fabric of reality. It's counterintuitive. The emptier the universe becomes, the more powerful the vacuum's influence grows. Emptiness is not absence, it is potential. The vacuum hums with a kind of invisible heartbeat, a low vibration that sustains creation even as it appears still. If you could somehow hear it, the sound would be beyond any frequency we know, a constant, soft pulse beneath all existence, the whisper of reality building itself moment by moment. This quantum ocean also creates one of the strangest forces in physics, known as the Casimir effect. When two mirrors are placed extremely close together, just a few nanometers apart, the vacuum between them behaves differently than the vacuum outside. Fewer quantum fluctuations can exist in the narrow gap, creating a tiny imbalance in pressure that pushes the mirrors together. It's a gentle but measurable proof that the vacuum is not void, but dynamic. Even nothingness has weight. The idea that space is active, that nothing can have energy, changes the way we think about existence. It means that the universe doesn't just sit upon a foundation of emptiness, it floats on an invisible sea of possibility. Every moment, the vacuum generates the ingredients of reality, allowing time, matter, and gravity to emerge from its unseen motion. And though these fluctuations are too small to touch or measure directly, they are everywhere, inside the atoms of your body, between the stars, beneath the darkness of intergalactic space. So, when we say the universe is silent, we mean only that we cannot hear its deeper music. Beneath the stillness, there is constant creation, the hum of quantum energy, the rhythm of existence continuing at the smallest scales. And perhaps, in that invisible dance of particles that appear and fade, we find a reflection of life itself. we too rise and vanish. Brief fluctuations in a larger pattern. But just as the vacuum never truly empties, neither does the universe forget the light that passes through it. Even the quietest nothing is full of beginnings. Even the darkest space is alive. Next, we'll drift from the smallest scales of the vacuum to the grandest structures of all the unseen halos that surround our galaxy and the vast sphere of matter that holds the Milky Way in its silent embrace. When we look at images of the Milky Way, we see a great spiral glowing arms of stars, rivers of gas, and clouds of dust circling a bright core. But what we see is only the surface, a luminous skin around something much larger and mostly invisible. Our galaxy is wrapped in a vast, spherical halo, a structure made of ancient stars, dark matter, and faint gas that extends far beyond the edges of visible light. This halo is enormous, more than 10 times the diameter of the galactic disk. If the glowing spiral of the Milky Way were the size of a coin, the halo would stretch as wide as a dinner plate. Though we cannot see it directly, we know it exists because of the way stars move. Their orbits don't match the gravity of the visible galaxy alone. Something unseen holds them steady, as though the Milky Way were cradled in invisible arms. Astronomers call this structure the galactic halo, and it may contain more than 90% of the Milky Way's total mass, mostly in the form of dark matter. Embedded within it are clusters of ancient stars called globular clusters, some more than 13 billion years old. These are relics of the galaxy's youth, survivors from the earliest eras of cosmic history. They orbit far from the galactic center, like lanterns adrift at the edge of night, each one carrying the chemical memory of the universe's first generations of stars. There's also gas, incredibly thin, but stretching across hundreds of thousands of light years. This gas forms the circumgalactic medium, a vast reservoir of material that feeds the galaxy's evolution. When stars die in supernova explosions, they throw heavy elements outward. Those atoms drift into the halo, where gravity and magnetic fields slowly recycle them back into the disk, forming new stars and planets. The halo, then, is not just a boundary, it's a breathing system, exhaling and inhaling the elements of creation. Recent observations from space telescopes like Hubble and Chandra have revealed that this halo glows faintly in X-ray light, heated to millions of degrees by stellar winds and ancient shocks. It surrounds us completely, though we cannot see it with our eyes. Every star you've ever looked at, every sunrise, every Milky Way photograph lies within this immense sphere of invisible fire. In a sense, the Milky Way is like an island floating inside a luminous atmosphere of its own making. The disk we see is only the heart. The halo is its soul, diffuse, ancient, and enduring. It carries the memory of collisions with smaller galaxies, of absorbed companions whose stars now drift silently among ours. We can still trace the remnants of those mergers, faint streams of stars wrapping around the galaxy like ribbons of starlight. They are the ghostly trails of systems that once were whole, now woven into our own. And yet, this invisible halo connects us not only to the past, but to the universe beyond. At its edges, the Milky Way's gravity blends with that of our neighboring galaxies, forming bridges of dark matter and gas that link one system to another. These cosmic filaments, strands of unseen matter, are the threads of the cosmic web, the grand structure that holds all galaxies together. You and I live deep within this unseen sphere, surrounded by forces we can't perceive but that define our existence. When you look up at the night sky, you're not just looking outward, you're looking from within a living structure, an invisible cocoon that has grown for billions of years. In that knowledge, there's a strange kind of peace. The galaxy protects us, holds us, and carries our story within its endless motion. We are not floating alone through the void. We are suspended inside a vast, unseen light. Even in the darkness, we are wrapped in history, in the quiet gravity of things that were born long before we were, still circling, still waiting, still whispering across time. The halo is our origin and our boundary, a reminder that what surrounds us may be more beautiful than what we can ever see. Next, we'll follow the light even farther back to the earliest galaxies ever seen, their faint glow reaching us from a time when the universe was still young, barely 200 million years after its beginning. Far beyond the edge of our Milky Way, the universe stretches into a tapestry of light and time. With the help of the James Webb Space Telescope, astronomers have begun to glimpse some of the faintest and oldest galaxies ever seen. Flickers of brightness that left their sources more than 13.5 billion years ago. These are not just distant points of light, they are memories of the universe's childhood. When Webb first turned its mirror toward deep space, it peered through billions of light years of expanding emptiness, catching photons that have been traveling since the dawn of time. Among them were galaxies so small and primitive that they barely resembled the spirals and ellipses we know today. They were clumps of stars bound together by gravity. Flickering in the cosmic dawn, the first organized structures to emerge from the dark. Each of these young galaxies was a furnace of creation. Inside, new stars ignited from pure hydrogen and helium, flooding the surrounding gas with ultraviolet light. This illumination ended what cosmologists call the cosmic dark ages, reionizing the universe and making it transparent once again. The darkness that had ruled since the Big Bang began to lift, replaced by the first steady glow of organized light. And though these galaxies were tiny compared to the giants we see now, their importance is immense. They were the architects of the modern cosmos, the first bricks laid in a structure that would grow into galaxy clusters, superclusters, and the vast cosmic web that stretches across billions of light years. Every spiral, every star system, every planet owes its lineage to these ancient beginnings. The light from those early galaxies has been stretched by the expansion of space itself, a process called redshift. What began as blue or ultraviolet light now reaches us as faint, cool infrared. Webb was built precisely to capture that light to see through time by detecting the soft, reddened glow of the first stars. Every image it sends back is not just a photograph. It is a time machine, showing us the universe as it was when it was only a fraction of its current age. Imagine gazing into one of these deep-field images. Every speck of light, every smudge, every faint arc represents an entire galaxy, each containing billions of suns. And among them are the truly ancient ones, shining from a time when the cosmos was still finding its shape. We are witnessing the first moments when gravity gathered chaos into order, when energy became form. In those early galaxies, elements like carbon and oxygen were being forged for the first time inside stars. When those stars died, they released those elements into space, enriching the gas that would one day form planets, oceans, and living cells. The atoms in your body, the oxygen you breathe, the calcium in your bones were born in those first cycles of stellar birth and death. You are, quite literally, built from the memory of the first galaxies. It's difficult to imagine the scale of that journey. A single photon of light leaving one of those ancient systems travels across the universe for more than 13 billion years before touching the mirror of a telescope or your eye. If you could see that far, during that journey, galaxies formed and collided, stars lived and died, entire civilizations rose and fell, and yet that single particle of light kept going, crossing the dark with quiet persistence. There is something deeply human in that image, a reminder that endurance is its own form of beauty. The light that began long before we existed now allows us to understand who we are. In seeing the first galaxies, we are, in a way, seeing the roots of ourselves. Every glimmer that reaches us from that ancient time carries a message, that creation is not a single moment, but a continuing act. That light never truly stops moving forward, even when the universe grows cold. And that memory itself, written in photons, may be eternal. So, as you drift tonight beneath your own sky, think of those fragile lights still traveling toward us, older than Earth, older than time as we know it. They are proof that even in its infancy, the universe already knew how to shine. Next, we'll step back and look at the grand design that ties those galaxies together, a cosmic network of filaments and voids that mirrors the shape of the human mind itself. When astronomers map the universe on its largest scales, a strange and beautiful pattern emerges. Galaxies are not scattered randomly through space. They cluster together along delicate filaments that stretch for hundreds of millions of light years, leaving vast, empty regions, cosmic voids in between. This interconnected structure is known as the cosmic web, and it is the grand architecture of everything that exists. Imagine looking down at a spider's web frozen in starlight, each thread glowing faintly, each junction a cluster of galaxies. That is what the universe looks like when seen from far enough away, a vast network of filaments woven from dark matter and gas, linking galaxies together like neurons in a brain. Where the threads intersect, gravity forms dense, not superclusters, the largest known structures in the cosmos. Between them lie the voids, enormous bubbles of near emptiness spanning hundreds of millions of light years. This pattern, intricate and delicate, arose from the tiniest ripples in the early universe, fluctuations in density magnified over billions of years by the pull of gravity. Where matter was slightly denser, galaxies formed. Where it was thinner, space expanded freely, creating the great gaps we see today. The result is both chaotic and symmetrical. And within this grand design lies an eerie resemblance to something deeply familiar. When scientists compared maps of the cosmic web to high-resolution scans of the human brain, they noticed a striking similarity. Both structures, one spanning the observable universe, the other confined within the skull, display networks of filaments connected by nodes, each transmitting energy, matter, or information. On vastly different scales, both appear to follow the same mathematical principles of organization. It's not that the universe is thinking, but the resemblance is haunting. In both cases, complexity arises naturally from simplicity. From a few basic rules: attraction, connection, flow, comes an emergent order, a system capable of holding patterns, of remembering, of growing. It's as if the universe uses the same geometry to build everything. From galaxies to consciousness, the cosmic web also reveals something extraordinary about light. When photons travel through this structure, they bend and scatter around filaments and clusters, distorting our view of distant galaxies. This phenomenon, called gravitational lensing, allows astronomers to trace the invisible scaffolding of dark matter that underlies the visible universe. By watching how light bends, we can literally see the shape of the unseen. Through these observations, scientists have learned that dark matter forms the backbone of the cosmic web. Ordinary matter, the stars, planets, and gas clouds we can detect merely fills in the spaces along those filaments, drawn into their gravitational embrace. Without dark matter, there would be no web at all, no framework for galaxies to form upon. The visible universe is just a thin layer resting on top of an invisible structure. When you picture the night sky, think of this. Every star, every nebula, every spiral galaxy is a bead strung along threads of darkness. The universe is not empty between those threads. It is structured by the unseen. Even our own Milky Way, with its halo of dark matter, lies along one of these cosmic filaments. It flows gently toward other galaxies in our local group, and together they drift toward something larger still. The Great Attractor, a mysterious region pulling entire clusters toward it across millions of light years. We are part of that flow, carried through the web by gravity's quiet tide. It's humbling to realize that the same laws shaping the smallest atom also sculpt the grandest structures in existence. From quantum fluctuations to galaxy clusters, from neurons to superclusters, everything follows the same rhythm of connection. In that symmetry, there's meaning not mystical, but mathematical, elegant, and deeply peaceful. The universe does not need to think to be beautiful. Its beauty is in the order that arises naturally from chaos. In the way light finds its path through the darkness. Perhaps that is the real lesson of the cosmic web, that everything, no matter how distant or small, is connected. Every star influences another. Every galaxy tugs on its neighbors, and every heartbeat, every breath, every flicker of awareness is part of that same unfolding pattern. We are not observers standing outside the web, we are strands within it, moving, glowing, and remembering. The universe is not beyond us. It is within us, woven into every atom of our being. Next, we'll leave this grand structure and turn our gaze toward the most mysterious objects it contains, stars that collapse into infinite density, bending light and time themselves. The black holes. Among the countless wonders of the cosmos, few inspire more awe or silence than black holes. They are the universe's deepest paradoxes, places where matter, space, and time collapse into a single point, where gravity becomes so powerful that even light cannot escape. They are not holes in space, but regions where space itself has fallen inward, a geometry turned upon itself, a shadow with infinite depth. Every black hole begins as a star that has reached its end. For millions or billions of years, a star's internal fusion pushes outward against the pull of its own gravity. But when its fuel runs out, the balance breaks. The core collapses, and in a moment of violent release, a supernova tears the outer layers apart, leaving behind a remnant so dense that nothing can stop its fall. If the mass of that remnant exceeds a certain threshold, gravity wins completely. The star implodes and a black hole is born. The boundary surrounding a black hole is called the event horizon. It's not a physical surface, but a point of no return. The distance from the center, where escape becomes impossible. Anything that crosses the horizon, light, matter, or even time itself, is drawn inward, spiraling toward the singularity, the place where all known physics ceases to apply. From the outside, however, black holes are not as dark as their name suggests. As matter falls toward the horizon, it forms a swirling disk of superheated gas that can glow brighter than an entire galaxy. Magnetic fields twist and accelerate the material, generating beams of radiation that shoot into space at nearly the speed of light. We call them relativistic jets. And they can stretch for millions of light years, visible proof that even in their silence, black holes can speak in light. In 2019, humanity captured its first glimpse of this mystery. The Event Horizon Telescope, a network of radio observatories around the world, produced an image of the supermassive black hole at the heart of galaxy M, 8753 million light-years away. What we saw was not the black hole itself, but its shadow, a ring of fire surrounding darkness. Light twisted and bent by gravity's pull. For the first time, we saw the outline of the unseeable. Black holes come in many sizes. Some are just a few times the mass of our sun, remnants of dying stars. Others, called supermassive black holes, contain millions or billions of solar masses and sit at the centers of galaxies. Ours, the one at the core of the Milky Way, is named Sagittarius A****. It's quiet now, but long ago, it may have shone fiercely, feeding on surrounding gas and dust, shaping the galaxy around it. There are even theories of primordial black holes, tiny versions that may have formed moments after the Big Bang, born from fluctuations in the early universe. If they exist, they would be relics from before stars, before galaxies, fossils of the first seconds of time. Yet black holes are not eternal. According to Stephen Hawking's groundbreaking work, they slowly emit radiation through quantum effects near the event horizon. This Hawking radiation causes them to lose mass, ever so slightly. Until, over unimaginable timescales, they evaporate entirely. The process is so slow that for most black holes, it will take longer than the current age of the universe, a quiet fade into nothing over trillions of years. It is poetic to think that even the darkest things in existence eventually release their energy back to the cosmos. Nothing lasts forever, not even gravity's strongest prisons. Black holes are the ultimate reminder of nature's balance. They are both destroyers and preservers, swallowing matter, yet revealing the universe's deepest truths. They warp space and time, but also connect us to the limits of knowledge, the horizon where understanding bends into mystery. And in their silence, there's a strange serenity. For all their power, they do not rage or roar. They simply are eternal, patient, and pure. They are the still points around which galaxies turn, the dark centers that allow light to dance. To look upon them is to look upon the edge of meaning, where the universe folds in on itself and whispers, "This far and no farther." Even there, in the heart of darkness, the universe remains beautiful, because even the things that devour light cannot escape becoming part of the light's story. Next, we'll listen to that story, to the ripples in space-time created when black holes collide, and to the cosmic music that lets us hear the universe itself move. When two black holes meet, the universe trembles. No explosion of light, no flash of color, just the deep, invisible movement of space-time itself. Two dark giants orbit one another in silence, drawing closer with each passing moment, their immense gravity distorting the fabric of reality like ripples in water. And then, in an instant that can last a heartbeat or 1,000 years, they merge and the universe sings. These songs are called gravitational waves. They are ripples in space-time, spreading outward from massive cosmic events. First predicted by Albert Einstein in 1916, they remained theoretical for a century, until 2015, when scientists at the LIGO Observatory detected one for the first time. It came from two black holes merging more than 1 billion light-years away. The signal lasted less than a second, but in that single moment, it confirmed that space-time itself can vibrate. To detect those vibrations, LIGO uses lasers stretched across 4 kilometers of vacuum tunnels. When a gravitational wave passes, it distorts space by less than the width of a proton, yet that tiny movement is enough to measure. It is as if the universe whispers in frequencies too deep for sound, and our instruments have finally learned to listen. Each wave carries information about its source, the masses of the black holes, their spin, the energy of their collision. From these subtle echoes, scientists can reconstruct the story of an event that occurred billions of years ago, long before Earth existed. It's as though the cosmos left behind a message, written not in light or matter, but in the geometry of reality itself. The power behind these waves is unimaginable. In the final moments before merging, two black holes can release more energy in gravitational waves than all the stars in the visible universe emit in light. Yet we detect it as a faint murmur, a distant sigh of motion across space. Energy and silence entwined, violence translated into calm. Since that first detection, dozens more have followed, black holes colliding, neutron stars spiraling together, the cosmos resonating like an ancient instrument. Each event adds another note to the great symphony of creation. We are now not only observers of light, but listeners of gravity. It's humbling to realize that the universe does not simply exist, it vibrates. Every planet, every star, every atom bends space-time just slightly as it moves. Every action, no matter how small, ripples outward, connecting everything to everything else. We are all part of a grand continuum of motion, woven into a fabric that never truly rests. When two black holes merge, they become one, their horizons fusing, their energy released in waves that race across billions of light-years, eventually brushing against detectors on a small blue world, orbiting an ordinary star. That subtle shiver of space-time passes through you too, though you don't feel it. Every few seconds, your entire body stretches and contracts ever so slightly as ancient events ripple past. The echoes of the cosmos move through us, constantly soft, eternal reminders that we are part of something vast and alive. The existence of gravitational waves also changes how we perceive silence. Even in the quietest void, space is never still. It bends, flexes, hums, a music too deep for the ear, too wide for the heart to hold. In that sense, the universe is not empty, but resonant. It carries memory as motion. The song of 1 billion collisions drifts through it, each wave stretching and fading until it becomes part of the background hum of existence. Someday, we may detect gravitational waves from the earliest moments of the Big Bang ripples left from the universe's birth itself. If that day comes, we will be listening to the first sound the cosmos ever made, the opening note of everything. Until then, every wave we detect is a reminder that even in darkness, movement continues. Even in silence, there is music. We are not apart from that song, we are made of it, vibrating gently within its rhythm. And so, when you close your eyes tonight, know this: the same universe that bends around colliding black holes bends around you as well. You are part of its harmony, its gravity, its infinite and gentle motion. Next, we'll follow those echoes further to the dying stars that fade not in explosion, but in rhythm, pulsing across millennia like slow, cosmic heartbeats. Not every star ends in fire. Some die slowly, fading not with an explosion, but with a pulse. These are the variable stars, suns that change in brightness over time, swelling and shrinking as they approach the ends of their lives. They are the quiet heartbeats of the cosmos, keeping time across millions of years. A variable star can change its light for many reasons. Some expand and contract as the heat from their cores shifts the balance between pressure and gravity. Others flicker because they are eclipsed by companions. Their light dimming as one star passes in front of the other. But among all these variations, there is one kind that pulses with a steady, rhythmic grace: the Cepheid variables. Cepheid stars are enormous supergiants, hundreds of times larger than our Sunday. Inside them, layers of gas trap and release energy in repeating cycles. As the pressure builds, the star expands, glowing brighter. As it cools, it contracts, dimming again. The process repeats, like breathing light exhaled into space and then drawn back in. Each pulse can last days or months, but the timing is exact, as reliable as the ticking of a celestial clock. It was through these stars that humanity first measured the true scale of the universe. In the early 20th century, astronomer Henrietta Leavitt discovered a simple truth. The brighter a Cepheid star, the longer its pulse. By comparing its rhythm to its apparent brightness, that insight became the first cosmic ruler, the tool that allowed us to step beyond our galaxy and map the depths of space itself. The Milky Way, Andromeda, the great clusters beyond all were revealed by the flicker of these dying stars. Their fading light became a bridge between galaxies, a message from one island of creation to another. Through their rhythm, we began to understand the vastness of everything. But there are other stars that pulse too, in stranger, slower ways. Red giants near death expand and contract over centuries, their outer layers drifting into space like sighs of light. Some white dwarfs, the cooling remnants of smaller stars, tremble faintly as they crystallize, their surfaces ringing with vibrations like the sound of a struck bell. Even in death, the stars continue to move, to resonate, to sing. Astronomers study these oscillations the way geologists study earthquakes. By observing the way a star vibrates, they can learn what lies beneath its surface, its density, temperature, and hidden structure. This science has a quiet name: asteroseismology, literally, the seismology of stars. Through it, we can listen to the echoes of stellar interiors, like doctors placing stethoscopes against the heart of the universe. The patterns are hypnotic, slow waves rippling through plasma, creating subtle rhythms that travel across light years. Each star has its own frequency, its own song written in temperature and gravity, and when we gather them together, their harmonies form the great chorus of creation, a music too vast to hear, but always playing. It's easy to forget, when we look up at the stars, that they are not static. They breathe, they age, they shift. They are living processes, not frozen points of light. The night sky is not a still image. It's a symphony slowed down beyond our perception. If you could speed up time, you would see stars pulse, fade, collapse, and be reborn. Galaxies would twist and flow like tides. Space itself would shimmer with the slow vibration of energy, turning the universe into a single, continuous song. And perhaps, in a way, that's what it already is. Each heartbeat of a dying star, each ripple of light traveling through space, each photon crossing eternity, all are notes in the same melody. We are surrounded by it, shaped by it, made from it. The stars that pulse are telling us a secret, that even as they die, they give life to meaning. Their rhythm becomes the universe's way of remembering them. A light fades, a pulse continues, and, from that gentle pattern, we learn to measure time itself. So tonight, if the sky seems still, remember that it isn't. Every flicker, every glimmer, every subtle shimmer in the dark is a heartbeat, steady, patient, eternal. The universe doesn't just exist, it breathes. Next, we'll drift beyond the stars to the quiet remnants they leave behind, glowing embers that cool over ages, and the slow transformation of starlight into silence. Every star that lives must one day fade, but not all fade in the same way. Some end in spectacular detonations, lighting up their galaxies for a brief, blinding instant. Others die quietly, their final light dimming over billions of years, a slow surrender of heat, until only cold memory remains. These are the white dwarfs, the silent embers of once living suns. A white dwarf begins as a star like our Sunday. For billions of years, it fuses hydrogen into helium, its light steady and warm. But eventually, the hydrogen runs out, and the balance between gravity and pressure starts to fail. The star swells into a red giant, shedding its outer layers into space. What remains is its core, small, hot, and impossibly dense. This core, no larger than Earth, but containing half the sun's mass, becomes a white dwarf. A fading jewel, glowing faintly in the dark. At first, its temperature exceeds 100,000 degrees, but with no fuel left to burn, it radiates its stored heat slowly into space. Over billions of years, it cools, fading from white to blue to red, and eventually to black, a black dwarf, cold and invisible. The universe, however, is not yet old enough for any star to have reached that stage. Every white dwarf ever formed is still glowing somewhere, a soft reminder that death in the cosmos is never sudden. It is a long, quiet fade. Inside a white dwarf, matter is compressed into an exotic state called degenerate matter. Atoms are stripped of their electrons, and those electrons are packed so tightly that quantum mechanics itself holds the star up against collapse. It is one of nature's strangest forms of stability, gravity trying to crush quantum pressure, resisting the two forces locked in eternal balance. Our own sun will one day follow this path. 5 billion years from now, it will exhaust its fuel, swell into a red giant, and cast its outer layers into space, forming a glowing cloud called a planetary nebula. At its center, a white dwarf will remain a crystal sphere slowly cooling for trillions of years. Long after Earth and its oceans have vanished, there is poetry in that fate. The same light that nurtured life will continue, quietly, into the deep future. Our star will not explode or collapse into darkness. It will fade into peace, becoming a small, radiant memory adrift in the night. White dwarfs are not the only remnants that tell stories of endings. All across the universe, vast bubbles of gas mark the graves of stars that died long ago, supernova remnants. The Crab Nebula, for instance, still expands from a supernova first seen by human eyes nearly 1,000 years ago. Its filaments of gas stretch across light years, glowing in every color of the spectrum. The ashes of a star carried on cosmic winds. Through those remnants, heavy elements like iron, gold, and carbon are scattered across galaxies, seeding new generations of stars and worlds. It is the ultimate cycle of creation. A star burns, dies, and spreads the materials of life. From its remains, new stars form, each carrying within them the memory of the old. The universe recycles its own light endlessly, destruction becoming the foundation for renewal. And yet, there is a stillness to it all. Even in the chaos of explosions, in the violence of collapse, the cosmos never loses its grace. It moves with patience, with purpose, with rhythm. Stars are born and die in perfect silence, and the galaxies drift on, serene as drifting clouds. The death of stars reminds us of the slow heartbeat of time, not measured in years or lifetimes, but in ages. To the universe, even a billion years is just a breath. So, when you look at the stars tonight, think of what they truly are, not just fires burning in the void, but stages of transformation, energy changing form, light remembering its origin. Some are being born, some are fading, some have already died, their final photons only now arriving here, crossing light years to meet your eyes. And within that quiet exchange, something eternal happens. The universe breathes through its stars, exhaling life and inhaling silence. Each ending is a beginning, each death another spark in the grand continuity of being. The cosmos doesn't mourn its stars, it transforms them into dust, into light, into the atoms that make you. We are, in truth, the residue of stellar death, living evidence that even in fading, the universe finds a way to shine. Next, we'll step deeper into that darkness, to the slow cooling of the universe itself, to the thinning of light and the long, gentle quiet that will one day come to everything that burns. In 2019, humanity saw the unseeable. For the first time in history, we captured an image of a black hole, or rather, its shadow, a ring of fire encircling a darkness that no light could escape. It was not a photograph in the usual sense, but a window into the deepest mystery of the cosmos, a glimpse of gravity itself made visible. The black hole lies in the heart of galaxy M87, 53 million light-years away. To create its image, the Event Horizon Telescope combined observatories from around the world, from Chile's Atacama Desert to the mountains of Hawaii and the frozen plains of Antarctica, forming a planet-sized array. For days, it watched the galaxy's core, collecting petabytes of data, which scientists then stitched together using algorithms fine-tuned to decode the language of light twisted by gravity. What appeared was astonishing, a glowing ring of gas and plasma orbiting at nearly the speed of light, heated to billions of degrees as it spiraled into oblivion. At its center, a perfect void, not black in color, but black in concept. The place where space folds in on itself. Around it, light bent by gravity's curve formed a halo, the last cry of matter before disappearing beyond the event horizon. That faint, blurred image, orange and gold against infinite night, changed everything. It was proof that Einstein's theory, written more than a century before, still held true in the most extreme conditions imaginable. It was also a reminder that even the darkest forces in the universe can be made visible if we learn to look in the right way. To gaze at that image is to feel time collapse. The light that formed it left M87 before humans walked the Earth. By the time it reached our telescopes, it had crossed 50 million years of expanding space. A single frame in an endless movie still playing across the cosmos. And yet, there it was, captured, frozen, revealed, a moment when the universe allowed us to look directly into its own heart. The black hole at M87 is massive beyond comprehension, 6.5 billion times the mass of our Sunday. Its gravity bends light into circles, its rotation drags space-time around it, and its jets of plasma stretch for thousands of light-years, piercing the intergalactic medium like lances of energy. It sits silently at the center of its galaxy, a dark engine shaping everything around it, from the orbits of stars to the birth of new systems. But perhaps what makes that image most profound is not its science, but its symbolism. For centuries, black holes existed only in equations, abstract ideas, too distant and too strange to see. And then, suddenly, they were real. Not just theories, but landscapes. Not just metaphors for mystery, but physical places where time itself slows and bends. In 2022, a second image was released, this time of Sagittarius A, the supermassive black hole at the center of our own Milky Way. It, too, showed the glowing ring of plasma around a silent core. To think that, hidden behind the haze of stars in the constellation Sagittarius, there lies a black hole 4 million times the mass of our Sun, and that we can now see it is nothing short of poetic. These images are not the end of discovery. They are the beginning. Each new observation reveals the quiet architecture of the universe, the way light and gravity sculpt reality, the way time itself can be stretched like thread. Every pixel in that glowing ring contains data about magnetic fields, temperature, and motion, the fine details of nature's most mysterious creation. But beyond all numbers, there's something profoundly human in this achievement. Across continents, hundreds of scientists work together for years to capture a single image of a thing that can never be touched. They turned the entire Earth into a telescope, synchronizing its rotation with atomic clocks, and aligned their minds to a single purpose: to see what cannot be seen. And in that collective act, there was a reflection of the very cosmos they studied, separate parts, connected by light and time, bound together across vast distances. Perhaps that's what makes this moment so moving. Not just that we saw a black hole, but that we became the instrument that saw it, a species aligned in wonder, peering through the dark. It was as if, for a fleeting moment, the universe looked at itself through our eyes and smiled. Next, we'll lift our gaze from that shadow and look with our own to the nearest great galaxy beyond our own, the Andromeda, whose light you can see tonight, even without a telescope. On a clear night, if you stand far from city lights and let your eyes adjust to the dark, you can see something remarkable. A faint, hazy oval floating above the horizon. It looks small, almost delicate, yet it holds within it 1 trillion stars. That soft glow is the Andromeda Galaxy, our nearest great cosmic neighbor, and it is already on its way toward us. Andromeda lies 2.5 million light-years from Earth. The light you see tonight began its journey before humans existed, before our ancestors even stood upright. Every photon that reaches your eyes has traveled across deep time, crossing the expanding void, carrying the memory of stars that may no longer shine. You are seeing Andromeda not as it is, but as it was, a living fossil of ancient light. Through telescopes, Andromeda reveals itself as a magnificent spiral, twice the size of the Milky Way. Its arms swirl with bright blue clusters of young stars, and its heart glows with the quiet heat of billions more. Between those arms lie vast lanes of dust and dark matter, silent scaffolds that hold the galaxy together. And, like our own, it harbors a supermassive black hole at its core, a gravitational monarch shaping its destiny. For billions of years, the Milky Way and Andromeda have been drifting toward one another, drawn together by their shared gravity. They are separated by immense distance, yet their paths are already intertwined. Astronomers have calculated that in about 4 billion years, the two galaxies will begin to merge, swirling together in a slow, graceful collision. Stars from both systems will pass through one another without ever touching the spaces between them so vast that even in impact, there will be no destruction. Instead, their combined gravity will sculpt new forms, pulling gas into tides that spark waves of new starbirth. When the merger is complete, the two spirals will become one, an enormous elliptical galaxy that astronomers have already given a name, Milkomeda. It will shine brighter than either galaxy alone, its core filled with the remnants of both. The night sky, if Earth or its descendants still exist then, will be a breathtaking panorama, ribbons of stars stretching from horizon to horizon, the heavens alive with motion. But the story is not about collision. It's about connection. The pull that will bring our galaxies together is the same force that binds every star, every planet, every atom. Gravity, quiet, invisible, patient, is the universe's oldest language. It doesn't destroy. It shapes. It sculpts. It draws things into harmony. Andromeda and the Milky Way are not adversaries rushing toward a crash. They are partners in a cosmic dance, orbiting their shared center of mass in a waltz that has been unfolding since time began. Each rotation, each drift, each subtle tug of motion brings them closer, not in chaos, but in grace. If you could speed up time, you would watch the two galaxies spiral together, their arms stretching and merging, their cores circling each other in a glowing embrace. For a while, the night sky would blaze with new stars as gas clouds collapse under the pressure of gravity's choreography. Then, over billions of years, the turbulence would settle, the galaxies blending into a single, luminous whole calm after creation. And though we won't be here to see it, that vision is part of our legacy. Because our galaxy and Andromeda are family siblings born from the same cosmic web, born to one day reunite, every atom of our existence is already part of that motion. We are participants in a grand, slow dance of matter and light. When you look up and glimpse Andromeda with the naked eye, you are seeing across 2.5 million years, witnessing the universe's promise of continuity. That faint smudge of light is both distant and familiar, a mirror across time, a reflection of what we are becoming. It's humbling to know that galaxies too follow the rhythm of attraction and balance, just like stars and planets, just like every heart that beats beneath the same sky. And that, in the end, everything moves not apart, but toward union. So as you watch the heavens tonight, let that thought drift through you. The light from Andromeda is already touching your eyes, and the gravity of your galaxy is already touching hers. Across space, across time, the universe is drawing its spirals together slowly, silently, beautifully. Next, we'll travel beyond this meeting of galaxies and return to something closer to the glow that fills every corner of existence. The first light ever freed, still echoing around you even now. All around you, in every direction, in every corner of the sky, there is light. You can't see it with your eyes, but it is there, older than any star, older than galaxies themselves. It is the cosmic microwave background, the faint afterglow of the Big Bang, the universe's oldest memory, still whispering across time. More than 13 billion years ago, the universe was not dark or empty. It was a seething sea of energy, hot, dense, and brilliant beyond comprehension. Matter and light were tangled together, constantly colliding, scattering, unable to escape each other's grasp. For nearly 400,000 years, the cosmos was opaque, filled with a glowing fog through which no light could travel freely. But as the universe expanded, it cooled. Atoms began to form simple hydrogen and helium, and the fog began to thin. For the first time, light was free to move. That light has been traveling ever since, stretching with the expansion of space, growing cooler, gentler, and softer, until today it reaches us as faint microwaves just a few degrees above absolute zero. It surrounds everything not as a beam, not as a glow, but as a quiet hum that fills the universe, like background music too deep to hear. Scientists have mapped this ancient light in extraordinary detail. In 1965, two radio astronomers, Arno Penzias and Robert Wilson, first detected it by accident while tuning an antenna in New Jersey. They were searching for radio signals from space, but found instead a persistent hiss that came from every direction, day and night. At first, they thought it might be interference, perhaps pigeon droppings inside the antenna, but when they cleaned it and the hiss remained, they realized what they had found: the echo of the birth of everything. Since then, missions like COBE, WMAP, and Planck have mapped the cosmic microwave background with breathtaking precision. What they reveal is astonishing. The universe, just 380,000 years old, painted in subtle patterns of temperature and density. Tiny fluctuations, only a few millionths of a degree, mark the seeds of all future structure. The spots where galaxies, stars, and eventually life would form. In that faint, mottled glow, we can see the blueprint of existence itself. To look at those maps is to look backward in time, to the moment when the cosmos first became transparent. Every point of light in the night sky, every star that will ever burn, all trace their origin to those early ripples. The universe we inhabit today is an echo, stretched and cooled, of that original brightness. It's humbling to realize that the same radiation that fills the void also flows through you. Right now, trillions of photons from the cosmic microwave background are passing through your body every second. They are the remnants of the first light, the afterglow of creation, bathing every atom in the memory of the beginning. In a sense, we are immersed in history, living inside the faint light of our own origin. That glow is everywhere, constant and patient, a quiet reminder that the universe still carries its childhood with it. The cosmic microwave background is more than a scientific relic. It's a message from the past. It tells us that the universe once glowed with warmth and light, and that from that brightness came all structure, all motion, all thought. It tells us that the cosmos began not in silence, but in radiance, and that radiance still lingers. If you could close your eyes and listen deeply enough, perhaps you'd feel it, the background hum of existence, the steady warmth of something ancient and kind. It is the light that never went out, the whisper that never stopped traveling, the signal that ties us to the moment of our creation. And in that thought, because no matter how far the galaxies drift apart, no matter how long the future stretches, that light remains woven into the fabric of everything. We live within the echo of the first dawn. Every sunrise, every photon that touches your skin, every spark of thought in your mind carries a fragment of that original fire. You are not separate from the beginning. You are its continuation. The universe began with light, and in some quiet way, it never stopped shining. Next, we'll come to the final reflection, not on the stars, but on ourselves, what it means to be made of stardust and to be the universe finally aware of its own existence. Of all the facts in astronomy, perhaps none is more quietly astonishing than this. You are made of stardust. The carbon in your cells, the calcium in your bones, the iron flowing through your blood, all were forged long ago in the hearts of stars that lived and died before the Earth was born. Every element heavier than hydrogen and helium was created inside stars through fusion. The same process that makes them shine. When massive stars reached the end of their lives, they exploded as supernovae, scattering their enriched matter across space. Those atoms drifted through the galaxy for millions of years, mingling with clouds of gas and dust until gravity drew them together again to form new stars, new worlds, and eventually, us. You are the universe made conscious, a collection of ancient particles arranged in such a way that the cosmos can look back at itself and wonder. The same laws that shape galaxies also shape your heartbeat. The same forces that bind atoms together bind your thoughts to the world around you. It's easy to forget this connection in the noise of daily life. We often imagine ourselves as small, separate beings moving through a vast, indifferent cosmos. But the truth is the opposite. We are not small things in the universe. We are the universe, briefly aware of itself. Every breath you take carries atoms that once belonged to ancient stars. Every molecule of water in your body has been through countless cycles, oceans, clouds, comets, and cosmic ice drifting between the stars. The particles in your hand could once have existed in a supernova explosion or inside the heart of a red giant. You are a pattern in motion, made of memory older than time as we know it. When you look at the night sky, you are seeing your origins not metaphorically, but literally. The light that touches your eyes left its source millions or billions of years ago, crossing space to reach the consciousness that those very stars helped create. The observer and the observed are the same story told from two perspectives, one written in light, the other in thought. There's something deeply comforting in that realization. It means that nothing is ever truly lost. When a star dies, its material becomes the seed of new creation. When you die, your atoms will return to the same cycle, scattered, reassembled, and reborn in other forms. Life and death are not opposites, but two halves of a cosmic rhythm, forever in motion. The philosopher Carl Sagan once said, "We are a way for the cosmos to know itself." And that is not poetry. It is physics. Your mind, your senses, your capacity to wonder, they are the result of billions of years of evolution, powered by starlight and gravity. Every neuron that fires, every dream you have, is part of the universe, learning what it is to exist. Perhaps that is the great purpose of life, not to control or to own, but simply to witness, to open your eyes and see the beauty of what is, to feel the rhythm of existence and recognize that you belong to it. You are not an outsider looking in. You are a participant in the grand unfolding of reality. Even the smallest act, a breath, a heartbeat, a thought ripples across space and time. It may not alter galaxies, but it changes the universe nonetheless, because consciousness itself is part of its fabric. Through you, the cosmos perceives its own creation. Through you, the stars remember themselves. And when you rest, when you close your eyes and let the world fade, the atoms that make you will continue their journey. They will drift and mix, and someday, perhaps, shine again. Your story will not end. It will transform. So tonight, as you drift towards sleep, let that truth settle softly in your mind. You are not a fleeting accident. You are the universe's way of experiencing beauty. Every heartbeat, every breath, every moment of wonder is a continuation of the first light that ever was. You are not beneath the stars. You are the stars, awakened and alive for a little while, shining quietly before returning to the dark. A spark in the infinite, a reflection of the universe remembering itself. Next, in the final 2 parts, we'll bring this long journey to its quiet close through gratitude, reflection, and the stillness that follows understanding. Because even silence, too, is part of the story of light. There is a moment, somewhere between thought and sleep, when everything becomes quiet. The mind drifts, the body softens, and the boundaries between self and space begin to blur. It's in that moment, in that stillness, that you can almost feel the universe breathing with you. The galaxies spin, the stars burn, and the atoms in your body hum softly, vibrating with the same quantum rhythm that shaped the first moments of creation. It's not imagination, it's physics. Every particle within you interacts with the cosmic background. Every atom carries a whisper of the Big Bang. Every breath draws in the remnants of ancient stars. When we think of the universe, we often imagine vastness, distances too great to measure, time too long to comprehend. But in truth, the same laws that govern galaxies also govern the space between your cells. You are a smaller version of the cosmos, a microcosm reflecting the same structure that fills the sky. Your heartbeat follows the same mathematics as stellar orbits. Your thoughts flicker with the same electrical energy that crackles through nebulae. To exist is to participate in this pattern, to be one note in a symphony that began long before you and will continue long after. And that symphony is not just sound or motion, it is consciousness. It is awareness, folding back on itself, like light reflecting endlessly through mirrors of time. As you lie here now, the Earth is moving, spinning at 1,000 miles per hour, orbiting the Sun at 67,000, circling the Milky Way at nearly 1,000,000. And yet, you feel still. That stillness is an illusion but also a gift. It allows you to listen. In this pause, you can sense what the stars have always known, that nothing is truly separate, that motion and stillness are 2 sides of the same truth. We drift, and yet we remain. We fall, and yet we are held. Gravity connects everything from planets to photons, from galaxies to your fingertips. You are floating in that web now, surrounded by invisible threads of connection. Every atom in your body is balanced by the pull of every other atom in the universe. Even across light years, the gravity of distant stars tugs gently at you, just as you tug imperceptibly on them. The universe is not indifferent. It is interwoven. In the great timeline of existence, your life is a brief spark, but in that spark, entire galaxies unfold. Every moment you experience, every emotion, every dream, is a unique configuration of matter and energy that has never existed before and will never exist again. That alone makes you infinite in meaning. The philosopher Alan Watts once said, "You are the aperture through which the universe looks at and explores itself." In other words, you are not a witness to the universe. You are the universe, aware of its own beauty. You are what happens when matter learns to feel, when starlight gains memory, when the cosmos, after 13 billion years of silence, begins to whisper to itself, "I am here." If you close your eyes now, you might feel the subtle rhythm of that whisper, the hum of your heartbeat syncing with the background pulse of the cosmos. The same force that drives galaxies apart flows through you, not as pressure or sound, but as stillness. You are not outside of the universe, and the universe is not outside of you. You are the same field of energy, briefly shaped into awareness. In this awareness lies peace, not the absence of thought, but the realization that thought itself is cosmic motion. Each idea, each memory, is a ripple in space-time, a temporary vibration in the infinite sea of being. When the ripple fades, the ocean remains, and the ocean is you. The stars above are not distant anymore. They are inside you, their light, their atoms, their gravity, their time. Every galaxy is a mirror, every night sky a reflection of your own inner horizon. So, rest now. Breathe with the rhythm of the universe. Let the mind drift as galaxies drift. Let silence speak where words cannot reach. You are not falling asleep. You are returning to the place where everything began and where everything will someday return again. Because to sleep, too, is cosmic. It is the body's way of rejoining the pattern. In stillness, you become infinite. In darkness, you become whole. Next, we'll drift into the closing reflections where light fades to silence, and silence reveals what has always been waiting beneath it. Gratitude, wonder, and the quiet realization that you were never separate from the stars at all. As the universe expands, the stars will fade, the galaxies will grow distant, and the echoes of creation will dissolve into silence. And yet, even when all light is gone, the story of the cosmos will not have ended, because its final act is not destruction, it is remembrance. The particles that once blazed as suns will drift through infinite space, no longer burning but still existing, still carrying the memory of what they once were. The laws that govern them will endure. Gravity, entropy, motion, time, and those laws, even in their quietest form, will continue to express the same truth that everything once glowed. There is beauty in this kind of stillness. It is not emptiness, but peace. The cosmos does not mourn its fading light. It becomes still the way an ocean becomes calm after the storm. A serenity earned through motion. That final calm is the universe's breath. A moment of equilibrium after eons of creation and collapse. In that distant future, when all that remains are cold particles drifting in a near absolute dark, the universe will still be balanced. It will still hold form, even if that form is silence. Because silence, too, is a kind of symmetry, the shape of what once was, preserved in stillness. From our human perspective, that future feels melancholy. We think of endings as loss, but the cosmos does not think in such terms. It does not know despair, only transformation. It does not weep when stars die, because death is not failure, it is evolution written in the language of physics. Every galaxy that forms, every supernova that erupts, every atom that cools, all follow the same rhythm. Expansion, reaction, release, rest. Each phase builds upon the last, adding layers to the symphony of being. Even when the instruments fall silent, the music remains written in the structure of the universe itself. And maybe that is what eternity truly means, not endless time, but complete understanding. A universe that knows itself fully, that has become all it can be, until there is nothing left to add. At that point, it no longer needs to move. It simply is. That same pattern exists in you when you quiet your thoughts. When the rushing noise of life settles, you enter your own stillness, your own version of cosmic equilibrium. The pulse slows, The breath deepens. The boundaries between you and the rest of existence dissolve. You become, for a brief moment, like the universe at rest, vast, and yet even in that stillness, you are not truly still. Your heart beats, your cells hum. The particles within you continue to vibrate with ancient light. You are both the silence and the motion, the resting ocean and the wave. You are the bridge between the universe's beginning and its eventual calm. In that realization lies gratitude, not for what you have, but for simply being, to exist at all, to think and to feel, to look up and recognize the stars as kin that is enough. It is the quiet miracle of consciousness, born from chaos, carried by time, returning to peace. When you think of all that had to happen for this moment to exist, the birth of the first atoms, the forging of elements in stars, the formation of galaxies, the rise of life on a pale blue world, it becomes clear that existence itself is a kind of miracle, not because it defies reason, but because it follows it so perfectly. You are living proof that the universe still dreams. Each thought you have is a continuation of its creation, another wave in the sea of possibility. And one day, when your body returns to dust and your atoms drift back into the cosmos, that dream will continue in other forms. Nothing is lost. Nothing ever has been. The universe will grow quiet, but in that quiet, it will remember everything, every pulse, every light, every voice that ever was. And in that memory, it will find peace. So when you close your eyes tonight, don't imagine yourself falling asleep. Imagine yourself expanding. Let your thoughts dissolve into the same calm that waits at the end of time. You are not ending. You are returning to stillness, to the same stillness that once gave birth to stars. Next, we'll enter the final two parts, a closing reflection on awareness, love, and the gentle truth that to know the cosmos is to know yourself. There comes a moment at the end of every journey when words fall away, when the mind, weary from searching, finds no more questions to ask, only quiet, only light, only the simple truth that you, this small, living consciousness, have been part of something endless all along. You began as atoms, born in the hearts of ancient stars. You drifted for eons through the dark, carried by gravity's patient hand. And one day, against all odds, those atoms came together to think, to feel, to dream. You became the observer, the one who could look up at the sky and recognize it not as chaos, but as home. Every heartbeat is older than the earth. Every breath carries the dust of supernovae. The molecules that form your body once belonged to rivers of plasma. To nebulae that glowed across light years. You are not separate from the universe. You are its continuation. You are the cosmos, made temporary, self-aware, and soft. And yet, being, we wonder, we grieve, we ache, because to know beauty is to know impermanence. But impermanence is not loss. It is participation. To exist, even briefly, is to be part of the universe's ongoing conversation between energy and silence. When a star burns out, it does not vanish. Its elements spread into the next generation of light. When you rest, your energy returns to that same cycle, never gone, only changing form. Perhaps that is what consciousness is, for not to control the universe, but to witness it, to stand inside its vastness, to marvel, to remember. The cosmos created eyes so it could see its own light, ears so it could hear its own silence, hearts so it could feel its own rhythm, and through you, it does. You might feel small beneath the night sky, but that feeling, that sense of awe, is not a sign of insignificance. It is recognition. The part of you made of stars remembers where it came from. The longing you feel when you stare at the Milky Way is not distance. It is memory, calling itself home. Even now, light from galaxies billions of light years away is traveling toward you. Photons that began their journey before Earth existed are only just arriving, brushing against your skin, whispering stories from the beginning of time. You are touched, every moment, by the universe's past, and with every heartbeat, you create its future. When this moment ends and the next begins, nothing truly leaves. You will dissolve into memory, into motion, into the soft, unfolding rhythm of the same creation that began all things. The stars will remember you because you were never separate from them. Every part of you, from your heartbeat to your thoughts, has already belonged to them and always will. So rest now, not in darkness, but in return. Rest in the rhythm of galaxies, in the quiet that cradles every beginning and every end. You have traveled through time and light and dust to arrive here to remember. You are not the end of the universe's story. You are the pause between its sentences, the silence before its next breath. And in that silence, it dreams again. The stars fade slowly beyond the horizon. The cosmic song grows soft, and the universe through you whispers one final line, a line it has spoken since the first dawn. You are the observer of infinity. Silence carries the sound of stars, and even in the dark, the light remains. Good night, and see you in the next video.